So a circle with equation x squared plus y squared minus 2x minus 4y minus 5 is equal to 0. Determine the coordinates of C, and of course C is the center, so to get C we need to put it in the completed square format. So we group the like terms, so we group the x's and we group the y terms, so y squared minus 4y. Bring over the 5 there, add 5 to both sides, so it's equal to 5. And then we complete the square here. So complete x squared minus 2x, I can take x minus 1 square. So this is x squared minus 2x plus 1, so minus 1, right? Remove that plus 1. And here, so y, we take half of the b value, 2, square it, we get 4, so minus 4 equal to 5. And then we can add 5 to both sides, so we end up with x minus 1 square plus y minus 2 square is equal to 5 plus 4 plus 1. So x minus 1 square plus y minus 2 square is equal to 10. So the center, which is what we call C, is equal to 1, 2. And of course, r squared is 10, so the radius, if you're asked, the radius will be root 10. Now remember, the equation for the line was y equal 2x plus 5. That's a line equation, a linear equation. And the circle was, we were told that, so we have a circle, center, we have a straight line that cuts a circle in two. Well, we don't know if the line cuts it in two, but we know for certain the line cuts a circle at two parts, A and B. So we have to find the coordinates of A and B. So we have a simultaneous equation problem here. So we substitute the line equation into the circle equation here. So here we see a y, we replace the y with 2x plus 5. Good, so x squared plus y squared, now y is 2x plus 5. So y squared is 2x plus 5 all square, right? Minus 2x minus 4 times y, and of course y is 2x plus 5. So minus 4 times y is minus 4 times 2x plus 5 equal to 0, equal to 5, sorry. Alright, so let us expand. So we have x squared. We expand this. So expand square root 2x, we get 4x squared. Square 5, we get 25. And then 2 times 2x times 5, that's 20x. Minus 2x. Expand this bracket, we get minus 8x minus 20 equal to 5. So we group like terms. Here we have 5x squared, x squared plus 4x squared. And grouping the x's, we have 20x take away 10x, that's 10x. And we have 25 minus 20, that's positive 5. And if we subtract 5 from both sides, 5x squared plus 10x is equal to 0. And of course we can factor out 5x, so we're left with x plus 2. So we equate both brackets to 0. To solve this equation, we divide by 5. So x equals 0 divided by 5, which is 0. Subtract 2 from both sides, x equal to minus 2. Now recall that y is equal to 2x plus 5. Alright, recall that. So to get the y value, y equal to, you replace x with 0, so y equal to 2 times 0 plus 5, which is 5. Here, now you substitute minus 2 for the x, so it's 2 times minus 2 plus 5. So 2 times minus 2 plus 5, that's positive 1. So A and B are the points 0, 5. Remember, A and B represents the locations where the graph, where the line cuts the circle. So it's minus 2 and positive 1. And that's what we're asked to prove, right? That's what we're asked to prove. So notice we're asked to show that the coordinates A and B are 0, 5 and negative 2, 1 respectively. And show that BC is perpendicular to AC. Now to show that BC is perpendicular to AC, we need the gradient, and we can use the gradient and compare them to know if two lines are perpendicular. Remember, if two lines are perpendicular, then their gradient, the product of their gradient should be minus 1. Alright, so let's test and see if BC is perpendicular to AC. So we're asked to show that the gradient of AC and BC have a product of minus 1, since we are told that these two lines are perpendicular. Let's find gradient. So this is A, B, and recall that the center was 1, 2. So the gradient of AC gradient is y2 minus y1 over x2 minus x1, right? So the gradient of AC, this is the x, this is the y, and then C, x, y. So I find the y difference, 5 minus 2. I find the x difference, 0 minus 1. That's 3 over negative 1, right? Or just negative 3. Good? Gradient of BC, so we're using the same formula, BC, x and y. So BC, the y difference, would be y minus 2. And the x difference would be minus 2 minus 1. So that's negative 1 over negative 3. That's equal to positive 3, right? So positive 1/3, positive 1/3. So notice if you take the product of AC, the product of these two gradients, alright, the product of these two gradients, you get negative 3 times a third, you get negative 1. So since the product of these two gradients is negative 1, it means that AC is perpendicular to BC. Alright? So therefore AC is perpendicular to BC. Determine the equation of a tangent to the circle at either point A or point B. Now, let me do a little sketch here. So here's the circle, point A, call point A, just so then a little sketch here, and tangent at A would look like that. I recall A was 0, 5. The center was 1, 2. So the gradient of this line, would have been was negative 3. So the gradient of the perpendicular line, as we found, this is a tangent line. It's a tangent line. So its gradient would be 1/3, which is since it's perpendicular to AC, and the gradient, remember the gradient of AC was -3, right? So the tangent gradient would be 1/3. So hence the equation y equal mx plus c, and of course to find c we know the point 0,5 is on the line, so the sub 0,5. So x is, so the y is 5, x is 0, so it's just c, alright? So c is 5. Alright, so c is 5. So therefore, equation of tangent is y equal mx plus c, and then m, that's 1/3 x plus c, which is 5. So part B, express p, q, and qr in this form here. So pq, simply q minus p. Q is what? 1, 2 minus 4 minus p, and p is 3 minus 1 and 2, and if we subtract, then 1 take away 3, that's -2, 2 minus -1, that's +3, minus 4 minus 2, that's -6. So it means therefore that PQ in this form is -2i plus 3j minus 6k. Also QR, that's r minus q. So r, what's r? -1, 1 minus 2 minus q, what's q? 1, 2, -4. So subtract -1, that's -2. 1 minus 2, that's -1. -2 plus 4, that's +2. So QR is equal to -2i minus 1j plus 2k. Now we are asked to show that the vector s, and the vector s would be what? The vector s would be ijk, so there's no i. So the coefficient for the i is 0, for the j is -16, and for the k is -8. Put it in that form. And we're asked to show that this vector s is perpendicular to through the plane PQR, which means that, so if perpendicular, then the dot product of s times PQ, must be equal to 0. Remember, if two vectors are perpendicular, that product should be 0. Or you could use s times that product of QR. It doesn't matter which one. The both should be 0. Alright, so let's find that product. So s, let's do the one for, let's do QR. It doesn't matter which one you do. S is 0 minus 16 minus 8. That QR is -2 minus 1, 2 equals 0. If I take that product, is 0 times -2, which is 0 of course, plus -16 times -1 plus -8 times 2. This will give us what now? The first term here is 0. This is +16. This is -16. So that product is 0. Alright, so hence s is perpendicular to the plane. And if we do it for PQ, it should be the same 0. Again, s was 0, -16, -8. PQ, what's PQ? PQ was -2, 3, -6. That product, multiply and add. So 0 times 0, that's 0 times -2, that's 0. -16 times -3, that's That's minus 48. That's minus 48, right? Plus minus 8 times minus 6, that's positive 48. So we also all get 0 also. So hence S is perpendicular to the plane through PQR, since that product is 0. So now we're asked for the Cartesian equation of the plane. And now we'll use the form Rn equal an, a dot n, where R is just x, y, z, n is a perpendicular, the perpendicular vector we just found, which is 0, minus 16, minus 8, same vector as S, the perpendicular vector. Again, we put n also here again, 0, minus 16, minus 8, and A is in a point, is a point in the plane. I can use minus 3, 1, minus 2, that's one of the points, right? And so we take the dot product, so x times 0, that's 0, y times minus 16, that's minus 16y, z times minus 8, that's minus 8z, is equal to minus 3 times 0, that's 0, 1 times minus 16, that's minus 16, plus 2, minus 2 times minus 8, that's positive 16. So we end up with minus 16y minus 8z is equal to 0. And that's the equation of the plane. Of course, what some persons might do is divide each term by minus 8. If I divide the minus 16 by minus 8, I get positive 2y. And divide the minus 8z by minus 8, I get positive z. And divide 0 by minus 8, 0. So this is also, I guess this is a simpler version of the equation for the plane. 2y plus z equals 0. Question 5, a function is given, so it's a piecewise function, and there are the pieces. Determine the limit as x approaches the left side of 0, negative 1 meaning the left side of 0. So the answer for this would be here. We're using this, the first function here, so it's square root of 0, which is 0. Right, since we're using the first one here, left hand side, which is the part for when x is less than 0. Part B, the limit of f of x as x approaches 0. Determine whether or not it exists and give a reason for your answer. So again, there's a function. If you should find f of 0, there's nothing for when x is equal to 0, right? So if we should try the left hand limit and the right hand limit, they are different. And f of so if of course if the function is not defined when x is equal to 0, and that is our reason. Look at the function there. X is less than 0, x is greater than 0. Good, so we are not given, the 0 is not a part of the domain. So the function is not defined when x is 0. We can also check the left hand and the right hand limit. If you notice the limit, we just found this to be 0. X is 0, right? And if you should find the right hand limit, of f of x, then the right hand limit here is 1. So notice this. So hence this is not equal to the left hand limit. So the right hand limit and the left hand limit are different. They are different. So therefore, limit as x approaches 0 of f of x does not exist. So that's our answer for part 2. So I rewrote the function there. We're asked to determine whether f is continuous at x equal to 1. So if it's continuous, f of 1 must exist. It certainly exists, right? So f of 1 exists. And f of 1 is actually equal to 1. As we can see there, right? Let's check the left hand and the right hand limit. The left hand limit to the limit of f of x as x approaches 1 from the left, that's equal to 1. And the limit of f of x as x approaches 1 from the right, which is this more than 1. So the square root of 1, which is 1. So left hand limit equal to the right hand limit. So therefore, f of x is continuous at 1. Determine the point at which the tangent to the curve x times root x is parallel to the line 3y minus y plus 6 equal to 0. Now we have a curve x times root x, but x times root x is x, and I recall that root x can be written as x to the power of half, right? So you add powers, that's x to the power of 1.5. So that's what x really is, x to the power of 3 over 2. So the tangent, remember we'll get the gradient by differentiating. Alright, so m, which is the gradient, is dy by dx, and dy by dx, so we multiply 3 over 2 times x, subtract 1 from the power, 3 over 2 minus 1, that's a half. So that's 1/2, of course half is root x, right? Now for this line, the gradient, what's the gradient of this line? So this is m, and this is for curve, right? And then for the line, if we transpose y equal to 3x plus 6. Alright, notice if you transpose this, you will get 3x plus 6. You will get 3x plus 6 is equal to y. Just add y to both sides. Alright, the group the y here. Y equal to 3x plus 6. And then, so dy by dx, so for line m equal dy by dx. And dy by dx is what? Positive 3. So they are parallel when the two gradients are equal. So hence, so parallel when gradients are the same, right? So therefore we equate the gradient for the line and the gradient for the curve. So the gradient for the curve is 3 root x over 2. And for the line, it's a constant 3. Now this is the equation we're solving. We can times both sides by 2 to get rid of the denominator there. So so therefore 3 root x equal to 6. And of course we can divide both sides by 3. So root x is equal to 2. And if we square both sides, x is equal to 4. Now recall that y is equal to 3x plus 6. Alright, so if x is 4, y is equal to 3 times 4 plus 6. 3 times 4, 12, 12 and 6, 18. So the point where these line and the curve are parallel, so point is x is 4. There's an error there. Actually, we need to use the equation for the curve. Since we're talking about a point on the curve, so we use the equation y equal x times root x. Y was also equal to that. And if x is 4, y is equal to 4 times root 4. And 4 times root 4, that's 4 times 2, right? Which is 8. So the y value here is 8, not 18. So we have a curve, we have a function, y equal the sine square cos x. We are asked to show that the coordinates of the stationary values of y are n pi and pi over 2 plus 2 n pi. So to get the stationary point, we equate dy by dx to 0, right? And then we solve. Now let's find dy by dx. So dy by dx for sine square. How do we differentiate such a function? Let me just, so dy by dx, equate dy by dx to 0. So dy by dx, so we're using the chain rule. The power there is 2, so 2 sine cos x 2 sine cos x now to the power of 1, right? So it's to the power now is 1, because subtract 1 from the power. So 2 sine cos x, and we differentiate sine cos x, which would be minus sine x cos x. Just rewrite it. Alright, so that's it. And from there notice that, so the sine x equal to 0 or cos x equal to 0. Right? Since if any of these are 0, then the entire expression becomes 0. And if sine x equal to 0, then the general formula is n pi, or n 180 degrees if you want to put it in degrees, without keeping it in radian, n pi or n 180 degrees. Alright, so pi radian is equivalent to 180 degrees. Here, the general formula, cos x equals 0, then x would be equal to 2n pi plus or minus pi over 2, and pi over 2 because cos 90 is 0, so this would be the primary angle. Or if you want to put it in degrees, 2 pi is 360, right? So 360n degrees plus or minus 180, that pi is equivalent to 180 degrees, so that's plus 90 degrees. So either of those would work as your solution. Determine the nature of the stationary values at x equal to n pi. So to get the stationary values, you would have to find the second derivative, and if it's greater than 0, and it's minimum, it's a minimum point. If it's less than 0, it's a maximum, and if it's equal to 0, we say it's a point of inflection. And for this one, it is actually less than 0, so the stationary point would be a maximum point. Question 6. By using substitution u equal 1 minus x, determine the integral of x into 1 minus x all square. Now, u equal 1 minus x. It means if you differentiate, du by dx is equal to minus 1. So du equal minus 1 dx, right? Or just minus dx. Now we can make the substitutions into this here now. So we're going to make some substitutions. Alright. So x from here, remember u is 1 minus x. So if I transpose, x is actually u minus 1. Alright, if I transpose this for x is actually 1 minus u, sorry. X is actually 1 minus u. And 1 minus x is u, so that's u square. And then dx is actually, transpose, dx is actually minus du. So minus du, I'm going to put the minus outside here. Let's integrate now, so I keep the minus out here. Before I integrate, let me just distribute this u. So distribute this u, I've got u times 1, that's u square. My u times u, that's u cubed. Into du. And I can distribute this minus outside here. I'll end up with u cubed minus u square du. And so if I integrate, add 1 to the power, divide by the new power for both of them. Plus the constant. And remember, what was u? U is 1 minus x. So I can replace 1 minus x to the power of 4 over 4. 1 minus x to the power of 3 over 3 plus c, and that's our integral. So given that f of t equal 2 cos t and g of t equal 4 sine 5t plus 3 cos t, show that, so let's integrate both. Let's deal with the left hand side. The left hand side is the integral of ft plus gt all together. So the integral of what's f of t? 2 cos t plus what's g of t? G of t is 4 sine 5t plus 3 cos t. So in that, integrate that in one instant with respect to t. So, alright, so integrate cos, we get positive sign, right? So 2 sine t. Integrate sine, we get minus cos, so it's minus 4 cos 5t over this differentiated, so over 5 over 5t differentiated, which is 5. Integrate that, we get 3 sine t plus constant. Let's deal with the right hand side now. The right hand side is the integral of separate, so integral of ft, so that's 2 cos t dt plus integral of g of t separately, which is 4 sine 5t plus 3 cos t. And you'll find you get the same thing, right? So integrate 2 cos t, we get 2 sine t. Integrate 4 sine t, we get the same thing, which is minus 4 cos 5t over 5 plus 3 sine t plus c. Notice the left hand side is equal to the right hand side. Alright, therefore proven. Alright, so we're asked to calculate the volume form by rotating the region enclosed by y equal to sin x, and between these two x values, pi over 2 and pi. So the volume is pi times the integral of y square dx between the x values. Alright, so x equal pi and x equal to pi over 2. Alright, so it's pi into, now y is sin x, so y square will be sin square x, right? Or sin square. And again, between pi over 2 dx, let's differentiate, integrate, sorry. Now you will recall that one of the trig identities is sin square. Sorry, no longer. One of the trig identities, let me just put it separate. One of the trig identities, let me put it over here, is cos 2x equal 1 minus 2 sin square x. So if I transpose for sin square, I have 2 sin square x equal 1 minus cos 2x. Divide both sides by 2, sin square x is 1 minus cos 2x divided by 2. So sin square x is 1 minus cos 2x divided by 2. So what I can do is rewrite the sin square x as 1 minus cos 2x divided by 2. So each term over 2. Dx between, of course, pi and pi over 2. So pi, and if I integrate half, I get half x. Integrate cos 2x, I get sin 2x over 2, and the 2 down here, so it becomes 4 between pi and pi over 2. Alright, so I form two brackets. In one bracket I substitute pi for the x. Alright, so replace x with pi, so this half pi, that's pi over 2, minus sin times 2 pi over 4. Now sin times 2 pi, that's 0, so 0 over 4, right? Minus, now I'll be substituting pi over 2, so this is now half times pi over 2, that's pi over 4, minus sin times 2 times pi over, no, 2 times pi over 2, that's pi, so sin pi, so also 0 again. Alright, so I'll have here now pi, and this pi over 2, minus pi over 4. Now pi over 2 minus pi over 4, that's equal to, multiply this by 2 and this by 2, that's equal to pi over 4, right? So the volume is pi square over 4 cubic units, right? You're talking about volume, so cubic units. So solution pi square over 4. And the final section, we're asked to solve this differential equation. Notice it's separable. Alright, we can just multiply both sides by dx dxy, or some people call it cross multiply. So y times dy is equal to x root x squared plus 1 dx. And of course we can take the integrals of both sides. Integrate y, we get y squared over 2. Integrate what we have on the right hand side. we'll have x squared plus 1. Well, this is to the power half, right? So we add a power, add 1 to that, we get 3 over 2. And of course, we divide by the new power, which is, we divide by 3 over 2, which is same as multiplying by 2/3, right? And to know if we add factorize this correctly, again, we can just differentiate and check using the chain rule. If we differentiate this, we'll get 1 outside, x squared plus 1. Subtract 1 from the power, x squared plus 1 to the power half. Differentiate what's inside, we'll get 2x. Alright, but you really want just x outside. So to get to it, of course, you'll put a 2 down here then. Alright, plus c. So therefore y squared over 2 is equal to x squared plus 1. Now it's very important to know that differentiation and integration, they are the opposite of each other. So if you integrate, we're claiming that we integrate this. We're claiming that when we integrate this, we end up with this. Which means that if we should differentiate this, we should end up with what we were asked to integrate. And you can just do a quick check. Differentiate this, you'll end up with x into x squared plus 1 to the power of a half. Alright? So remember now we're solving for, we're told that when x is 0, y is 2. So this will help us to find the value of c, the constant. So when y is 2, this will be 2 squared over 2, so we'll have 4 over 2. And when x is 0, we would have 1 to the power of 3 over 2. Now 1 to any power is 1, so 1/3 plus c, which means that this is what 2, so 2 minus 1/3 is equal to c, which means that c would be 1 2/3. So therefore, the solution, we have y squared over 2, so it's y squared over 2 is equal to, taking from this now, x squared plus 1 to the power of 3 over 2 over 2 plus c, and c is 1 2/3, or you could say c is 5 over 3. And of course, you could times each term by 2. If you times this term by 2, you'll get y squared. Times this term by 2, the 2 will divide into itself. And if you times this by 2, you'll get 10 over 3. Alright, so that will be our equation. And that's it.